Hello everyone. So mostly today I'll be discussing this problem score after flipping matrix, which is the Leetcode daily problem for 13th May 2024. In this problem you have been basically given an m cross n binary matrix grid. A binary matrix being all the elements in the matrix can either be 0 or 1. And a move basically consists of choosing a particular row or a column and toggling each value in that row or column. Basically toggling means changing all zeros to ones and all ones to zeros, and then every row of the matrix can be interpreted as a binary number, and the score of the matrix will be the sum of all these numbers, right? So after making a certain number of moves, we might be making zero number of moves, we have to return the highest possible score that is possible, right? So for example, in example 1 we can see that 3 such moves have been made. So for the first move, the 0th row has been flipped, and for the second move, the second column has been flipped, and for the third move, the third column has been flipped, and ultimately we calculate the score of the matrix, which is 111 in binary, which is 15 in decimal, plus 1001 in binary, which is 9 in decimal, plus 1111 in binary, which is again 15 in decimal, which is 39. So that is the maximum possible score we can get. So in order to solve this problem, we have to first keep in mind the contribution for each bit in a particular m bit binary number, right? So the contribution for the most significant bit will be 2 to the power m minus 1. Then second bit will be, m minus 2th bit will be 2 to the power m minus 2. Then ultimately for the least significant bit, it will be 2 to the power 0, right? So if you really see, we have to focus on first making all the cells in the first column 1, right? If we make all the cells in the first column, we can have this contribution by all the first cells in the first column. So we can get the first column score as n into 2 to the power m minus 1. So this will, we'll obviously want the numbers to be as big as possible. So for a particular number to be big, obviously we will always benefit if the most significant bit is 1, right? The m minus 1 bit is 1. So this is our primary focus. So let's just focus on this thing first, that we want to make all the cells in the first column equals to 1. So let's say I have been given a matrix which has the first cells as something like this: 0 0 1 1, then maybe 0, then again 0 0, then 0. Yeah, so as you can see, there are 5 zeros in the first cell. So we have to make these 5 zeros 1. So what is the best way to make that? So we can flip this particular rows. We can flip the first row, the second row, the third row we don't flip, the fourth row, the second row and the third row we don't flip, because the first cell is already 1, and the rest of the rows we flip, right? So after this, what we will get is 1 1 1, and rest of the columns will be, rest of the cells in the same column, in the first column, will be 1. That's what I'm trying to say. So ultimately after this, the contribution by the first column will be power of 2 to the power m minus 1 into the total number of rows, because every cell in the first column will be equal to 1, so the total number of ones is equals to n. Okay, 2 to the power n minus 1, basically the number of columns is n and the rows is m. Okay, so now that we have fixed the first column, and now we are going to iterate over the rest of the columns. So let's iterate over rest of the columns, j from 2 to m minus 1, n minus 1. And now if you see, I don't have the choice of flipping this particular flipping a particular row anymore. Why? Let's say I try to flip the first row after this particular move that we have made all the ones in the first column. If we try to flip any row, then the cell in the first column will be 0, right? So we don't want that. We want all the column cells in the first column to be 1. So after this particular move, we don't have the provision to make the choice of flipping a particular row. So only what we can do is flip a particular column. So let's say I'm at a particular jth column. So how do I choose if I want to flip this particular jth column or not? So let's call 1 to be the number of ones in the jth column and 0 the number of zeros in the jth column, right? So how do I choose if I want to flip this column or not? So if let's say I have the if let's say 1 is basically greater than 0, right? The number of ones is basically greater than 0. Then I can say I don't want to flip this column because I already have the maximum number of ones that I can get in this column, and the score will be calculated for this particular column will be n minus 1 minus j into basically 1. Or otherwise, if the number of zeros is more, then I will flip this column and the number of zeros will be then the number of ones, and the number of ones will be then the number of zeros, and ultimately the score will be calculated as n minus 1 minus j into 0. So basically that's the basic way of choosing whether I want to flip a particular column or not. And also, why am I doing n minus 1 minus j? So in a particular vector, I mean in C++ or any other language, the indexes will be from left to right, but in binary system obviously the index happens from right to left. So 0 comes at the rightmost bit and then 1 and then so on, right? So I'll calculate the index from the back. Okay, so that's mostly it. Basically I first fix all the ones in the first cell, first column in all the cells, and then consecutively iterate over all the cells, iterate over all the columns from 2 to n minus 1, and then calculate the maximum possible score that we can get from this particular column. So that's mostly about the solution. Let's try to code it. Grid will be, the number of rows will be m, and n will be the number of columns, right? And let's also define a function which is flipping a particular row. Flip row, which will take the grid and the index of the row that we want to flip, and we are going to basically iterate over all the columns. All the columns in that particular row and flip every cell. Right. Okay. Now I have the answer variable and I'm going to iterate over the first column first, right? Okay. And if I see that grid of 0 comma j is not equals to 1, then obviously, as I said, we need to flip this particular row. So the row will be, okay, no, this will be 1 to m. Basically we are iterating over the row and we have the column fixed, right? So this is that, and flip this ith row. And after this step we have basically made all the cells in the first column as 1, so answer will be updated by power of 2 to the power n minus 1 into m. Now we are going to iterate over the rest of the columns, which will be 1 to m minus 1, right? Yeah. And now I calculate the number of ones and the number of 0 in this particular column. If grade of ij is 1, then update 1, else update 0. So ultimately the answer for this particular column will be 2 to the power n minus 1 minus j into max of 1 comma 0. Return answer. So mostly this should work. Okay, what did I do? So yeah, I am doing all right here, and I'm checking if it is 0. If it is 0, then I'm flipping this particular row. And how do I flip this particular row? Okay, yeah, that works. And now I'm iterating over the rest of the columns, and I'm calculating the ones and zeros. Okay, yeah, j less than n it should be, and I less than m, right? So yeah, mostly this should work. Yeah, so that's about it for this problem. Mainly this problem was based on greedy algorithms only. So yeah, thanks everyone.